In this video, geometry students will be looking at 5 ways, shortcuts, to prove that a quadrilateral is a parallelogram. Okay? So here we go. Your heading for today is proving quadrilaterals to be parallelograms. Okay? Proving quadrilaterals to be parallelograms, lesson 6.4. Go ahead and copy that down in your notes if you would, please, and be sure to include today's date. Okay? Be sure and include today's date. Alright? Okay, let's continue on. Now, please understand that we know only one way right now to know for sure when a quadrilateral is a parallelogram. Okay? We only know one way. And what is that one way? Well, when both pairs of sides are parallel to each other, then we know that we have a parallelogram. Okay? So, if you had a quadrilateral that looked like this, and you had arrows here, and arrows here, then you would know for sure this side here is parallel to this side here, and you would know this side here is parallel to this side here. So then you would know for sure that you had a parallelogram. Okay? But right now, that's the only way that we know to prove that a quadrilateral is a parallelogram. Okay? Now, today I'm going to show you 5 other ways to know for sure that a quadrilateral is a parallelogram. Okay? 5 other ways. Now, remember yesterday we looked at 4 properties of parallelograms. Okay? Remember that? Those properties were opposite sides. I'm not going to write those down. I will just quote them to you. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, and diagonals bisect each other. Okay? Those are the 4 properties we learned yesterday about parallelograms. Now, today, we are going to use the inverses of these 4 theorems to come up with 4 ways to show that a quadrilateral is a parallelogram, plus one other way. So we're going to take our 4 properties from yesterday, and we're going to take their inverses, okay? And then, and those inverses will help us come up with 4 ways to show that a quadrilateral is a parallelogram, and then plus, we're going to learn one other way also, okay? So let's go ahead and get started. Here we go. Here's the first theorem for today. Please copy this down. Theorem 6.7. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, copy that down, please. So here's our first way to know that a quadrilateral is a parallelogram. If both pairs of opposite sides are congruent. Let me say that again, okay? If both pairs of opposite sides of a quadrilateral are congruent, then we know the quadrilateral is a parallelogram. Okay? Now copy this down, please. And then copy this down over here. Okay, here we go. Put a mark here, put a mark here, put 2 marks here, put 2 marks here. Okay, if AB is congruent to DC and AD is congruent to BC. If that happens, then we know for sure that A, B, C, D is a what? Parallelogram. Okay, guys? So let's pretend that I gave you a parallelogram and I put an 8 here and an 8 here. Watch that parallelogram. Let's pretend that I gave you a quadrilateral, and this side here was 8, and this side over here was 8, and this side here was 10, and this side here was 10. You would know right away that this quadrilateral is a parallelogram, because anytime these two sides here are congruent and these two sides here are congruent, then you know for sure that you have a parallelogram. Okay? So that's the first way to prove that a quadrilateral is a parallelogram, when both sets of opposite sides are congruent. Okay? Alright, continuing on. Now, you do not have to know the proof of this theorem, okay? But I'm going to quickly, very quickly, go over the proof for you. Please do not try to take notes, okay? You might injure yourself, okay? But listen while I show you the proof for this theorem. Okay, students, first of all, here's the theorem right here, okay? Remember, your if part is your given, okay? And your then part is your proof part. So here we go. Now, here's your diagram, okay? You have a quadrilateral. Here's your given if both pairs of opposite sides are congruent. So, one mark here, 2 marks here, 2 marks here. AD is congruent to BC, and AB is congruent to DC. We're going to prove that this quadrilateral is a parallelogram. Now, students, think about it. The only way that we know to prove that this is a parallelogram is if I can prove that this side here is parallel to this side here, and I have to prove that this side here is parallel to this side here, and then I can state that ABCD is a parallelogram, okay? That's my goal. So watch how I do this, okay? I'll go very quickly. I will not be long-winded. Just watch and don't try to take notes, okay? Here we go. Number 1 is your given. Number 2, draw a line AC. So I draw a line right here. And notice I label these angles 1, 2, 3, 4. Okay? Now watch this. AC is congruent to AC. Reflexive, okay? So this side here is congruent to itself. Okay, moving on. Triangle ABC is congruent to triangle CDA. Okay, so this triangle here is congruent to this triangle here. Okay, how do I know that? Side, side, side. In my given, I already stated that AD is congruent to BC and AB is congruent to DC. And right here, I stated AC is congruent to AC. So because of that, I can state that these two triangles are congruent by side, side, side. Okay? Now, moving on. Angle 1 is congruent to angle 4. Okay? By CPCTC. Now, guys, think about this for a second, okay? Look, if angle 1 is congruent to angle 4, look at this. I've got a line here, and a line here, cut by a transversal. And we learned that whenever two lines are cut by a transversal in such a way that the alternate interior angles are congruent, then these two lines here are parallel. So now look what I can state. I can state that AD is parallel to BC because alternate interior angles are congruent. Now look what I put next. Angle 2 is congruent to angle 3 by CPC DC. I know that because this triangle here is congruent to this triangle here. Now look, guys, watch. Here's a line here and a line here being cut by a transversal like this. See that? And this angle here is congruent to this angle here. Well, remember, whenever two lines are cut by a transversal in such a way that their alternate interior angles are congruent, then I know these two lines here are parallel. So I can state that AB is parallel to DC because of alternate interior angles are congruent. So look, guys, look what I stated right here. So I'm going to mark that. Arrow here, arrow here. Look what I stated here. So two arrows here, two arrows here. So now I ran out of room, guys, so I couldn't put step 9 on here. But step 9 is A, B, C, D is a what? Parallelogram. Because definition of a parallelogram. I mean, guys, look, as soon as I stated that this side here and this side here were parallel, and as soon as I stated that this side here and this side here were parallel, then by definition of a parallelogram, I know that A, B, C, D is a parallelogram. Okay? So there's the proof kind of quickly. You don't need to know that, but I wanted you to see it, okay? So you kind of get the idea of what we're doing. All right, let's continue on. Okay, now students, here's theorem 6.8. Go ahead and copy this down, please, okay? If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram, okay? Sorry about the spelling right there. If both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, copy that down, please. I'll wait just a second for you to do that. Okay, now look, guys, copy this down, please. Here's your quadrilateral. Okay, copy that down, please. If angle A is congruent to angle C and angle D is congruent to angle B, then we know that A, B, C, D is a what? Parallelogram, okay? So, if this angle here is congruent to this angle here, and this angle here is congruent to this angle here, then I know for sure that this quadrilateral is a parallelogram, okay? Now, guys, look. If I put an angle here like 100 degrees and 100 degrees, and here I put 80 and 80, then you would know for sure that you have a parallelogram. Because notice, these two angles here are congruent. And also notice, these two angles here are also congruent, okay? So one more time, whenever opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram for sure, okay? Now you're going to prove this in your homework, okay? When you do the homework assignment from this lesson, you will prove theorem 6.8, okay? Okay, moving on to the next theorem. Okay, theorem 6.9. If an angle is supplementary, now look, guys, to both of its consecutive angles, then the quadrilateral is a parallelogram. Okay, copy that down, please. If an angle inside your quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram, okay? Let me give you a picture of this, guys. Copy this down, okay? Let me give you a picture of this. Okay, students, go ahead and copy this down. Here's your quadrilateral. Now, please, students, watch this carefully, okay? Please watch this very carefully. We have quadrilateral ABCD. Now, usually I come over here and I give you if, and I give you then, okay? I'm not going to do that. on this example, just watch over here, okay? Pretend this is 110 degrees, okay? Pretend this is 70 degrees. Now, please don't miss this. A lot of students see that these two consecutive angles are what? Supplementary. They add up to 180, and so they assume right away that they have a parallelogram, and that's not true. It says if an angle is supplementary to both of its consecutive angles. So look, here's 110. Okay, this is 70. This angle over here also has to be 70, and that way 110 is supplementary to this angle here, and it's supplementary to this angle here. Then you know the quadrilateral is a parallelogram. Okay, look, guys, you have to have three angles written in such a way so this middle angle here is supplementary to these angles here, like this. Okay, now it could be like this. It could be that we have 70 in the middle here and 110 here. That would be okay, because here's your middle angle, here's your consecutive angle, and here's your consecutive angle right here. Okay, if you add these two here, you get 180. If you add these two here, you get 180. Thus, you know for sure that the quadrilateral is a parallelogram. Okay, now you're also going to prove this theorem here in your homework also when you do homework from this lesson. Okay, all right, moving on to your next theorem. Go ahead and copy this down, please. Theorem 610. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay? If the diagonals bisect each other, then you have a parallelogram. Okay, copy that down quickly, please. Copy that down quickly. And here we go. Okay, parallelogram A, B, C, D. Okay, draw your diagonal. And draw your other diagonal right here. Okay, we'll call this point E. Okay, if, now watch this carefully, students. Watch carefully. If AE is congruent to EC, and DE is congruent to EB, then you know for sure that ABCD is a what? Parallelogram. Got it? So anytime you have a quadrilateral and the two diagonals intersect in such a way that they bisect each other, then you know for sure that your quadrilateral here is a parallelogram. Okay? That's theorem 610. Alright? Theorem 610. Okay, now you will also prove this theorem here in your homework when you do homework from this lesson. Okay? Alright, moving on. Theorem 611. Go ahead and copy this in your notes, please. Copy this down, guys. If one pair of opposite sides of a quadrilateral, one pair, guys, just one pair, is congruent and parallel, then you know that the quadrilateral is a parallelogram. Okay? If one pair of sides, opposite sides, is both congruent and parallel, then the quadrilateral is a parallelogram. Okay? So go ahead and copy this down. Okay, copy this down. This is quadrilateral A, B, C, D. Now look what we're going to do here, guys. Look, we're going to say that this side here is congruent to this side here, and it's also, this side here is also parallel to this side here. So if AD is congruent to BC and also AD is parallel to BC, then we know for sure that A, B, C, D is a what? Parallelogram, okay? Let's go over that again. If just one pair of sides is both parallel and congruent, then we know for sure that we have a parallelogram, okay? It's so important you know these guys, all right? Now, you are not responsible for the proof of Theorem 6.11, but if you would like to see the proof, it is located on the bottom of page 288. So if you're interested in seeing the proof for this theorem, it is located here at the bottom of the page, okay? Now, let's quickly review the 5 ways to prove that a quadrilateral is a parallelogram, okay? Let me get a drink here real quick. Okay, let's continue on. Now let's quickly review the 5 ways to prove that a quadrilateral is a parallelogram, okay? Here we go. Number 1, when both sets of opposite sides are congruent, then you have a parallelogram, okay? Number 2, when both sets of opposite angles are congruent, then you have a parallelogram, okay? When one angle is supplementary to both of its consecutive angles, then we have a parallelogram, okay? When the diagonals bisect each other, then we know that we have a parallelogram, okay? And then number 5, when one pair of sides, opposite sides, are both congruent and parallel both, then you know that you have a parallelogram, okay? So there we go. Now students, please learn these. Please know these, okay? That's it for the video today. I hope this has been a help to you. If you have any questions, don't hesitate to call or email.